Assalamualaikum and hello everyone. Welcome to the video for 5.2 Alkene. Where in this video, we will learn to illustrate the mechanism of electrophilic addition of our hydrogen halide. Here, HClO HBr. Okay, so this will be the third mechanism that we have learned in 5.2 and overall the fourth mechanism in chapter 5 lah. Okay, so this will be the last video for the mechanism and the last video for chapter 5 itself. So on your notes, it will be on page 22. Okay, so for the electrophilic addition of hydrogen halide, the name of the reaction is halogenation or hydrohalogenation of alkene. Okay, this reaction is electrophilic addition because remember our alkene is a electron-rich site. So here we have our nucleophilic site. So what species will be added to our nucleophilic site? Our electrophile lah, hence electrophilic addition. Okay, for the case of the halogenation or the hydrohalogenation ni, what we're gonna add, one is we're gonna add hydrogen, another one we're gonna add our halogen. So the halogen can be bromine or chlorine. Again, the electrophilic addition will follow the Markov-Nikov rule, where the electrophile, in this case our hydrogen, will be added to the carbon with greater number of hydrogen. So without further ado, let's look for the first example, ethene. Okay, so for the reaction of ethene, we're going to add it with HBr. Okay, again, what we're going to determine is the how many carbon attached to the carbon-carbon double bond. Because why? We're going to we're going to write down the hydrogen to the one with more carbon with more hydrogen. The halogen will be added to the one with less hydrogen. But when we look for the carbon here, this carbon attached to it 2 hydrogen. This carbon pun attached to it 2 hydrogen. So kat sini it's fine. Any of the atom will be added. Kat mana pun it's fine lah, because there's no cases of carbon more hydrogen, carbon less hydrogen. But then what I'm going to take is actually this one. What would happen? First, for the addition reaction, okay, sebab there's no need to consider yang more ataupun less hydrogen ni kan. So, okay, just gonna remove the double bond, but we will add 2 new bond. Okay, what we're gonna add this case, based upon our reagent itself, HNBr. So, we add lah HBr. Itu sahaja. So, that is actually for the reaction equation. How about the reaction mechanism? Reaction mechanism ni straightforward saja. Only 2 steps. For me, the most simple mechanism in chapter 5. Okay, so first one is the formation of carbocation and the halide ion. So carbocation ni C+, halide ion ni, it means that contohnya Br minus or Cl minus, halide ion X minus. Okay, so how does this reaction work? So we're gonna take our reactant, our alkene with our HBr in this case. But then I want to show the bond here between H and bromine. So it will be easier to see the bond breaking, bond making. Okay, so how's the movement of the electron? Still, we're talking about 2 electron. We're going to use full-headed arrow. So maknanya curve, full-headed. Okay, so how does the movement, the mechanism? Okay, so from the rich electron to poor electron. Okay, rich electron ni, walaupun yang worse, the atom has more electron lah. Dekat sini kan banyak electron kan. Okay, remember for the electrophilic addition ni, memang first step what we're going to take is actually add hydrogen. So sebab tu from our double bond ni kita the movement of electron, the electron will move towards hydrogen. Sebab remember first one the electrophile or hydrogen will be added to the carbon with more hydrogen. So dalam case ni what we're going to take is from our double bond we'll be moving towards hydrogen. Okay, so what happened to the HBr? So when the carbon takes one of the hydrogen, this bond will break. Okay, so when this bond will break, it will move towards more electronegative atom. Okay, group 17 is considered the most electronegative lah. The ability to attract electron sangat tinggi because it needs only one more electron to achieve octet. Okay, so the bond will break, it will move towards bromine itself. Okay, tapi yang ni ada lain sikit. We have to show that this reaction is a slow reaction. Okay, kenapa reaction ni slow? Because both of these compound is actually a stable compound. Later kita tengok macam mana pula yang fast tu. Okay, so again, for this reaction, remember that the hydrogen must be added to the one with to the one carbon which has more hydrogen. But in this case, it has the same case lah kan. It has the same number of hydrogen attached to each carbon. So tak kisahlah mana-mana. So what I'm going to do is actually, okay, remove the double bond. Okay, we know that we're going to add one hydrogen. Okay, so one of the carbon add one hydrogen kan. Make sure yang more hydrogen lah. Carbon with more hydrogen. The next to it tu, we're going to add our carbocation. Okay, kiranya it has donated the electron to hydrogen, to take the hydrogen. So one ni akan jadi positive. What happened to our bromine? Okay, so bromine ni, it will become Br. But since it has achieved, it has accepted the electron for the bond breaking, so it become a negatively charged. Okay, so that is for step 1. Simple sahaja. But make sure, remember, for the carbocation, determine the stability tu, ataupun compare, determine the classification. Here is primary carbocation, next pun primary. So, do we need to do any 1,2 hydride or CH3 shift? There's no need lah. Okay, so the next step, the step 2 is that we're going to take the product from step 1, okay, to become step 2. Okay, so what happened here, it mentioned that the halide ion will donate electron to carbocation. So, from the rich electron species yang ada negatif ni, dia akan donate electron to the one with a poor electron species yang positif ni. So, kita buatlah from bromine towards our carbon. Make sure the full headed arrow. Okay, so in this case, kita akan guna arrow, but we have to include is a fast reaction. Okay, why is it a fast reaction? Sebab dalam case ni, kan dia adalah ion kan, so it wants to be a neutral molecule, so the reaction is fast lah compared to our stable, when we have our neutral compound, a stable compound. It's a bit slow, ini will be a fast reaction. Okay, so apa yang akan tambah? So what we will have here is actually, so from here kita akan buat so bromine tu will be added to our carbon. So letaklah dekat sini bromine. Okay, since it has donated the electron, so dia dah tak adalah negative sign tu. So dia jadi positive, negative, cancel out. Yang carbon ni pun dia accept electron negative, so cancel out juga. Okay, that is the mechanism for the halogenation or hydrohalogenation of alkene. Simple sahaja. It's a bit straightforward. Paling simple lah in chapter 5 ni. Okay. So, just to make sure, yang kalau a bit tricky for the formation of carbocation, don't forget to determine the classification to know whether we have to rearrange or not. Okay. So, next one, what we're going to look at is 2-methylpropene. So for 2-methylpropene, again, before the reaction, I want to know which one has more hydrogen and which one has less hydrogen. This carbon attached to it has 1, 2. So this one has 2 hydrogen. So it means that this is the one with more hydrogen. This carbon attached to it 1, 2 CH3. So overall, there's no hydrogen. So when there is no hydrogen attached to it, so it means that this is the one with the less hydrogen. Okay, so for the addition, remember, hydrogen will be added to the one with more hydrogen. Okay, so it means our chlorine will be added to the one with less hydrogen. Okay, so what will happen to the product? So I'm just going to put here. So the product will be, I'm just going to remove not only the explanation, remove the double bond. We're going to form 2 new bond. 1, 2. So again, yang ini because it has different classification kan, different more hydrogen ataupun less hydrogen. So make sure hydrogen is added to the one with more hydrogen. So kat sini will be added our H. So here will be our Cl. Okay, so yang ini, so ada straightforward sikit kan. Yang ini Miss boleh buat straightforward sahaja. So okay, so let's do it lah. Okay, so that's for the first step. Remember, the formation of carboxyl ion ni check the classification. Here is actually our tertiary carboxyl ion. Sebelah dia ni primary, primary. So there's no need for the rearrangement. So bolehlah kita buat straightforward sahaja the second step of this mechanism. Okay, so this the one is the product which follows the reaction equation itself. Ni straightforward saja. Make sure don't forget to include the slow and fast. Okay, so that is actually for the reaction of 2-methyl propene. Okay, the last but not least, what we're going to look at is for the reaction of 3-methyl butene. Okay, for the reaction of 3-methyl butene, let's do it together. Remember that for the addition reaction, we have to determine which one has the more hydrogen, which one has the less hydrogen. Okay, to determine to know which part ataupun which carbon will be added hydrogen. Okay, which atom we has the hydrogen, which atom will have the bromine. So here, this one, this carbon attached to it 2 hydrogen. Okay, this carbon attached to it 1 hydrogen, 1 alkyl group. So here it means that here attached 2 hydrogen. So the more, this one attached to it 1 hydrogen only. So it will be less. Make sure that memang carbon-carbon double bond ni is the one that has the hydrogen. Yang ini memang confirm kan this one yang ada 2 hydrogen. This one attached to it only 1. Yang lain ni is our alkyl group itself. Okay, so how about the addition? It means that this one will be added our hydrogen. Add hydrogen. This one will be added with our bromine. Okay, make sure we remove the double bond. So we do get our hydrogen, bromine. Okay, so that is actually the reaction equation. So now let's do the mechanism. Again, step 1 is actually the formation of carboxyl ion. So here I believe pun boleh fast forwardkan juga. Okay, so that is actually for our step 1. Okay, so this is the mechanism. Okay, what should we do next is actually for the carboxyl ion, we always have to check whether to check the classification of the carbon itself. Whether we should rearrange it or not. So in this case, okay, kena tengok yang betul-betul next to it lah. Okay, this one is actually a secondary carbon. Okay, next to it is actually attached to it. This carbon attached to 1, 2, 3. So attached to it is actually 3 carbon, so tertiary carbon. This one is primary. So again, is it the most stable? Is it the most stable carboxyl ion? No lah. We can form the tertiary carboxyl ion. So what should we do here? Is actually we have to show that what we have is the 1,2 hydride shift. Okay, 1,1,2 hydride shift. Here what will happen is that we will shift the hydrogen lah. Okay, 1,2 hydride shift. Okay, why it is not a CH3 shift? Sebab kalau ada 1,2 CH3 shift, nanti dekat sini masih secondary, sini nanti it is still the same lah. Nanti CH3 dekat sini, positif dekat sini, masih lagi sama, carboxyl ion secondary. Okay, the CH3 shift can only occur when the substituent dekat sini memang tertiary CH3 ataupun quaternary carbon. Okay, so here what we're going to write down is actually write down using yellow 1,2 hydride shift. Okay, so what would happen is that here kita akan dapat our reaction to be this one still the same. So what will happen? The shifting is actually regarding our hydrogen here and our positively sign here. Okay, so dekat sini what would happen is that positive will be changing towards here. Positive will be this one. and the CH3, the hydrogen will be this one. So when we check the classification, our carbocation ni is actually tertiary carbocation, and my carbon next to it is ini primary. This one is actually my secondary. So again, this is the most stable carbocation lah. So from here, then we can do our step 2. So step 2, straightforward sahaja. Which carbocation that we're gonna take? From this one. Okay, so this is actually our product. So when we look based upon our equation, it seems different. So which one is the correct one? The one that is the correct one is actually when you draw the mechanism lah, because actually we have our hydride shift here. Okay, so again, if you're a bit unsure, you can look for the rearrangement. Again, if the rearrangement is also discussed in the dehydration of alcohol as well. Okay, so that's it, the last video for chapter 5.